Hi folks, in this video I'm going to show you how to perform a paired sample t-test in Excel and then how to match it in JASP. So in this data set, we're going to explore a population of people that live with Alzheimer's disease or some other type of related dementia. And so effectively what happened is a group of researchers were interested in knowing if the number of disruptive behaviors was statistically different among this population of people when there was a full moon compared to when there was not a full moon. And so what they did is they had 15 participants, and on moon days, they quantified the number of disruptive behaviors that were had on those days. And then they compared those data in the same group of people to the number of disruptive behaviors on non-moon days. And so in order to perform this type of analysis, we're going to need to use a paired sample t-test, whereby d bar represents the average difference, and that is going to be divided by the standard deviation for the difference, and it's going to be divided by the square root of n. So we'll go ahead and jump over to Excel and show you how to do that. Okay, so once I have my data in Excel, I'm going to go ahead and put my formula in here because that's just going to help me calculate things step by step. So in terms of being able to understand how these data are interpreted, this is going to be a little bit different than how we ran the one sample t-test and the independent samples t-test. What we want to do here is we first have to calculate a D, and that is not deviance, that is delta or difference score. So I'm just going to literally write difference to make sure that it's super clear. And to calculate the difference, we're going to take the moon days and we're going to subtract it from the non-moon days, right? And so we're going to do that for each of the 16 participants in this study, and I'm going to be able to generate an average for those difference scores, or a mean of the differences. And so this effectively 2.4326 is representing the average difference, which is the d bar, the average difference in the sample. And so in order to calculate and find the standard deviation, remember there's no squared units here, I then need to calculate the deviance of that difference. So to calculate that, I'm interested in this person's difference minus the average difference in the sample. That's $C, that's $17. And so when I go ahead and do that, I get deviance scores for those values. And of course, if I sum those, I'm going to get a value that is 0 or very close to 0. And you see that with the exponent. So I need deviance squared. And so I'm going to square all the deviances just like I've done for other t-tests this term. And when I generate that value, and we sum that, we'll see that we have our sum of squares total. And then to get our variance, we're going to take the average of that. So we take equals the sum of squares total divided by n minus 1. In this case, we're talking about the number of pairs. And so there are 16 pairs. Minus 1 restriction is 15. And so if I did that, I get a variance of 1.99. If I took the square root of my variance, I get a standard deviation of 1.41. Okay, so standard deviation is 1.41. And I could verify that to make sure that my math is correct by equals standard deviation. And I can run my standard deviation of the difference scores, and I get the exact same number. So that's how I know that I calculated those numbers correctly. The other aspect of this that I need is a square root of the sample size. So there's 16 pairs. So if I take the square root of 16, I'll see that I get 4. And so I have all the pieces now that I need in order to calculate my t-test. And so the t-test is going to be calculated by taking my numerator, which in this case was 2.432, and my denominator is going to be calculated by taking the standard deviation that we had of 1.41 and dividing it by the square root of n, which was the 4 in this case. So here you have your 0.345. So you have your numerator and your denominator, and so your t observed would be the numerator divided by the denominator, and you get a t of 6.89. Well, if we then go back to our t table, two-tail alpha 0.05, we have 16 participants, or 16 pairs, I should say, minus 1 degree of freedom is 15. And so our alpha level is going to be set to 2.131. So our alpha level is going to be set to 2.131 is our T crit. And so if you look at your T crit, you have your T observed of 6.89, which clearly exceeds 2.131. So let's go ahead now and run this in JASP. And once again, I'm opening this up in JASP. You would open up the app, go to Show Main Menu, open Data Library, T-Tests, and you would come down to where it says Moon and Aggression. And in this case, remember, if you were using this with your assignment data set, you would first have to take the data, put it into Excel document, convert it to a .csv, and then upload the .csv into JASP in order for this to function. And so there's been videos on how to do that. So make sure to refer back to those videos if you need help. So to go ahead and run the t-test, I'm just going to go to t-tests. I'm going to go to paired sample t-test, and I'm interested in these two data. I'm going to move the variable pairs over, and you can see that it's automatically generating the T. But again, I want to make sure that I verify the basic assumption of normality, which assumes that the distribution of the D is not statistically different from a perfectly normal distribution. And so we see that that's the case because the p-value is larger than 0.05, which tells us that our distribution of the difference scores is not statistically different from the perfectly normal distribution in the population. And so when we compare our paired sample t-test to the calculation value that we have in Excel, you can see that the p is smaller than 0.05, and you can see that the t-value is 6.452, which is pretty close to the t-value that we observed of 6.89. Generally speaking, we want the t-value to be within 0.5 hundredths of the actual t-value observed. And so as long as you do that, you will receive full credit for this assignment. And so what does this actually mean, right? Well, we have to go back and determine the descriptives. And so if we run the descriptives of the number of disruptive behaviors on moon versus non-moon days, you can see that because the T observed was statistically significant, that the average number of disruptive behaviors tended to be higher on moon days compared to non-moon days. And so this would mean that on moon days, staff should be more aware that people that live with dementia may have a greater likelihood of experiencing a disruptive behavior than they otherwise would on non-moon days. And so this walks you through the process of how to understand the context of what a paired sample t-test is, how we would calculate the data in Excel, and then how we would verify our data in JASP. And so I hope this video was helpful, and we'll see you all in the next one.